right, time for a pop quiz. So, what is the shortest path from source to destination noted by node S and node D? Right? What's the shortest path? So pause for just a second. Right? And if you said the shortest path from S to D, that's a cost of 100, then you're absolutely correct, right? That makes sense, right? S to D is 100, but if I go around this salt mall cycle over here, S to A to B back to S, that's 500 plus 500 plus 1, so that's 1,001 more, right? So that would be 1,101 total cost to get to D if I went around this cycle. Now, let's change that question just slightly. So now, what is the shortest path? Alright, so if your answer is something along the lines of whatever I want it to be, then your answer is correct, right? You can make this as low as you want because this cycle over here is a negative cycle, right? If I go from S to A, that's 500, but if I go from A to B, that's negative 500. So those cancel out. And then from B back to S, that's a negative 1 cost, right? So by going around this cycle, we netted negative 1, and now if we go from S to D, we can hit 99 cost from S to D. Now that's the shortest path, S, A, B, S to D, okay? So, but there's nothing stopping us from going around a cycle multiple times, especially when it comes to finding the cheapest cost. So S to A to B, right? Do that once, you net, and doing this cycle once nets you a negative 1. Doing it again, negative 2. And again, total of negative 3. So that would give us a cost of 97. In fact, we can go around this as many times as we want, right? And get so there is no cheapest cost because there's no shortest path because I can always go around this cycle one more time and say, no, that's even cheaper. So this kind of graph where we have a directed graph with a negative cycle in it, right? And that's this thing over here, where we have a negative cycle in it. That's where Dijkstra's fails. It will not be able to work properly on a graph with a negative cycle. And in that case, you want to try hitting some other algorithms. For instance, in the algorithms class, you will learn about Bellman-Ford, which will be able to at least detect the presence of a negative cycle, right? So there are solutions out there, but this is where Dijkstra's fails.